Okay, here we go. Today is March 11th. Okay, here we are at 0 radians. What's the order pair? 0, 1, 0. What's our first angle measure here? Pi over 6, and it's radical 3 over 2 and up a half. Here in the middle, pi over 4. Radical 2 over 2. Good. Up here is pi over 3. Comma radical 3 over 2. Yeah. And then right here would be pi over 2, and that order pair is 0, 1. Okay. Very good. It's really, really important that you know the unit circle. And clearly, quadrant 1 is the most important because all the others are just reflections, sign changes. So as long as you know that, that's pretty good. It is important that you know the angles. So right here would be 2 pi's over 3. Here is 3 pi over 4. Here is 5 pi over 6. This is pi. Here is 7 pi over 6. Down here, right center. Over 4. Something over 4. 5 pi over 4. Very good. This one is over 3. 1 pi over 3. 2 pi over 3. 4 pi over 3. This is 1 pi over 2. 2 pi over 2. 3 pi over 2. Yes. Right here is 5 pi over 3. 7 pi over 4. Not quite to 8. 11 pi's over 6. Very good. Okay. Really, really important that you know your angles because today this is what we're looking for. We want to know what angle has a sine ratio of radical 2 over 2. Or what angles have a cosine ratio of radical 3 over 2. Okay? And you have to know both of them. Okay? So we are going to be solving some trig equations today, and it's all based on that wonderful unit circle. So I encourage you, go to YouTube, type in memorize the unit circle or something about unit circle, okay? And there's all sorts of videos of people telling you silly things to remember stuff.
Have you seen the hand one?
Yes, I know the hand one. I'm not a huge fan of the hand one, but x-axis, y-axis, yes, here's your 30-degree angle,
Yes.
45, 60, yeah.
This is 30.
So, yeah, 30, 45, 60, and when you do 30, it's radical 3 over 2, comma 1/2. Yeah, it's okay. I'm not a huge fan. Yeah,
I can't remember.
all right, here we go. Example 1, solve the equation on the interval from 0 to 2 pi. All right, so you do want to check your answers because when in doubt, all of the equations that we're going to do, you can use your calculator for. So on test day, even if you don't know the math, when in doubt, use your damn calculator. That's what you have them for, okay? So, the problem with using your calculator, it can get complicated to learn how to type it in. You need to practice. So, I definitely want you to check at least 4 problems today using your calculator. Verify your answers. Because come test day, if all the math fails your brain, okay, you go to the calculator, and I have answers for A, and answers for B, and answers for C, and answers for D. Check my answers. So if you learn how to check, then it shouldn't be a problem to do that method on the test, and that's fine. Here we go. We want to say 2 sine of theta equals -1. We are solving equations. We are solving just like we used to solve for x, except our goal is to isolate the trig function. So we want to get the sine of the angle all by itself, which means we need to divide by 2. Exactly right. So we get the sine of some angle is -1/2. The sine is isolated, the trig function is isolated, and this is where I go to my unit circle and I think to myself, where does sine have a value of -1/2? Nope.
Wait, hold on. Is it negative?
No, wait, it's 11 times 6.
Yeah, there's an answer. Right here. Okay, so that's one answer. Hold that thought and say that again in just a second. Where's the other one that has a sine value of -1/2? Diagonal, like here in quadrant 2?
No, it's in. No, it's in.
Quadrant 3, right here? What angle measure is that? 7 pi over 6. 7 pi over 6 and 11 pi over 6. You gotta know them. All right, so they both have that sine value of -1/2. That's where sine has a value of -1/2, and we're looking for those angle measures. 7 pi over 6 and 11 pi over 6. Now, that's fantastic. Who was it that said -pi over 6? Noel. Okay, so Noel said -pi over 6, which is not incorrect. It is coterminal with 11 pi over 6. But we want our angle measures to be between 0 and 2 pi. So between one rotation of our unit circle. And so -pi over 6 is obviously less than 0, so we wouldn't want to use that answer. But it's not incorrect. It's just not in the range that we want. Okay. Yes, sir. Well, so that's a good question. Sine inverse, if we use sine inverse, it would only give us one solution, which would be -pi over 6. Yes. Yes, we want all of the possible solutions. And the reason is because I want you to check. I really want you to understand what's happening here. So to check an equation, you can always solve any equation. We put the left-hand side in y1 and the right-hand side in y2. So I'm going to do that. So in my calculator, I'm going to type in 2 sine of some angle x in y1, and in y2, I'm typing in -1. I'm going to go ahead and just do a zoom trig. Trig window, zoom trig, and the Casios have it as well. It's a trig viewing window, I believe, viewing window trig. And so there's our left-hand side. We only want the solutions from 0 to 2 pi. I'm actually going to change my window so it just goes from 0 to 2 pi. So that's just one revolution of our unit circle. And so here's our 2 sine of theta. So middle, high, middle, low, middle. And there are the 2 intersection points where, okay, so now I can check. Is it working? What mode are you in? This one is going from -4 to 4.
Should I be in radian?
Radian mode, radian mode. If you're not getting a curve, it's because you're in degrees. Oh, gotta be in radian mode, radian mode. Now I can just use trace on my answer. So I'm gonna do trace and type in 7 pi over 6. And there it is. Tinkerbell is right at the intersection, and that's where it equals -1. I can type in 11 pi over 6. And there it is, Tinkerbell at that other intersection point, okay? So using your calculator to check is super useful. You absolutely want to know how to do that. So really good question about using the inverse function, which is normally you could, but we wanted our answers between 0 and 2 pi, all of the answers.
Wait, what did you?
I typed in my answers. 7 pi over 6. Okay, no. Unhighlight it rather. All right.
Just switch lanes.
Left-hand side in Y1, right-hand side in Y2. Okay. All right, here we go. Letter B here. What do you want to do first? Nope. Add one. Add one. So we get 3. Tangent squared of theta equals 1. And then what? Now we can divide by 3. Very good. So we have tangent squared of theta is equal to 1 over, 3. Is the tangent, what else do we need to do? Square root. Square root both sides. Don't forget plus or minus. Yeah, when you take a square root, you need to remember plus or minus. All right, so that gets tangent by itself, which is what we wanted. On the right-hand side here, we're going to get the square root of 1 over the square root of 3. What is the square root of 1? All right, so this sort of cleans up to 1 over radical 3. I'm going to leave it like that. I don't actually want to rationalize it because that's just an extra step I need to do. At this point, I'm going to go right to my unit circle, and I want to know, where does tangent have a ratio of 1 over radical 3, positive or negative? So I'm going to go to my unit circle, and just look in quadrant 1 right here. I have 3 different choices. Is it in the middle? No. That's radical 2 over 2. I can ignore him. This one at pi over 6. What is the ordered pair at pi over 6? Radical 3 over 2 and 1/2. How do you figure tangent? Y over x. Sine over cosine. The tangent of the angle would be 1/2 over radical 3 over 2. And the 2's reduce, leaving you with 1 over radical 3. So that looks like a winner right there at pi over 6. Gives me positive 1 over radical 3. Then, where's another solution? Quadrant 3 right here. 7 pi over 6 is true. That also is positive 1 over radical 3. What else? What about negative?
Oh, yeah.
5 pi over 6 and 11 pi over 6. Positive or negative? So normally, you're going to have 2 solutions normally, but not all the time, but many times. When it's plus or minus, you end up doubling that. It'll be twice as many. So again, this is something you can check. I do not like checking when I have my tangent function being squared. That's really hard to type into my calculator. So I'm going to go ahead and just put this in Y1 and this in Y2. Hopefully I did all my math correctly. So I'm going to check here. How do you do plus or minus? You do 2 equations. Tangent of x in Y1. And then I'm going to do 1 over radical 3 in Y2. And negative 1 over radical 3 in the third equation. All right, because I can't do plus or minus. So it's just 2 separate things. Okay? I'm going to go ahead and hit graph. There's our tangent, toes to nose curve. 1, 2 intersections for 1 over radical 3 and 1, 2 intersections underneath there. And again, I can just use trace and type in pi over 6. And it is at that little intersection place right there. And 5 pi over 6. There's the other one, again, intersecting with our tangent curve. 7 pi over 6 up above. And 11 pi over 6 right there. So all 4 intersections look good, okay? Really, really, really good to check. I lovingly call these the bow tie triangles, right? Looks like a bow tie, right?
No way.
Hello. Okay, here we go. Okay, we have 2 cosine squared of twice our angle is equal to 1. This is called a double angle. This is twice what we want. All right, so we're actually going to solve for twice what we want and then get the angle that we actually want. We want to isolate our trig function. What should we do first? Divide by 2, divide by 2. So we have cosine squared of twice our angle is equal to 1/2. And then what do we need to do? Square root both sides. Don't forget. Plus or minus. The square root and square cancel out. So we have cosine of twice our angle is equal to, so square root of 1 over square root of 2. 1 over radical 2. Now this one, that doesn't look familiar, does it? What do we need to do to this one? Rationalize. Yeah, so it's radical 2 over 2. Radical 2 over 2. Okay, so, and it is plus or minus, yes. Okay, so at this point, I'm going to go ahead and go to my unit circle. However, before I do that, how many answers are you expecting? 4. Okay. So let me ask you a question. Let's think about the graph. Let's think about the graph of this function. What does that 2 do? First of all, what's the cosine curve? What's the cosine song? High, middle, low. High, middle, low, middle, high. What happens when we put a 2 inside?
It's got high.
Really high, very middle.
What do you mean it doubles?
Like,
So it's important to think about that. Let's see what happens when we graph it. We're expecting to see high, middle, low, middle, high, right?
This is not negative.
Okay, so, oh, what happened?
Sine.
What did it do?
There's 2.
There's 2 periods, yes. It's not 1 period anymore, it's 2 periods of the cosine curve. So we have lots of solutions. So that too causes a horizontal compression. How many solutions are there going to be? 8 solutions. Okay. So there's actually 2 periods for this function. What I'm going to tell you is we actually, whenever we have what's called this multiple angle here, we're going to use our unit circle But we can't do just one rotation. One rotation is one period. We need to do 2 rotations. So 2 rotations of our unit circle. Watch what happens here. So looking at my unit circle, I know all the radical 2's over 2 occur on the over 4's. So I'm going to wrap around my unit circle. So right here, this angle is what? Pi over 4. 1 pi over 4. What's this one? 3 pi over 4. 5 pi over 4. 7 pi over 4. That's one wrap around of our unit circle. Here's 8 pi's over 4, and we're going to keep on counting. This becomes 9 pi's over 4, and then 11 pi's over 4, 13 pi's over 4, 15 pi's over 4, and that's as far as I need to go. Let me go one more just to see what happens. So that's 15, 16. This would be 17. So we'll talk about that in just a second. So what we did is we did 2 rotations because this graph is really 2 periods, okay? Now, that was twice the angle that we are looking for. So how do we get theta by itself? Divide by 2. I don't like to divide by 2. What else could I do? Yeah, I'm going to multiply everything by 1/2. What is pi over 4 times a half? Pi over 8. 3 pi over 4 times a half. 3 pi over 8. And that, okay, got the pattern now? Okay, so that becomes 5 pi over 8, 7 pi over 8, 9 pi over 8, 11 pi over 8, 13 pi over 8, 15 pi over 8, and 17 pi over 8. Now, I added on that 17 pi over 8 because I want to reiterate that theta is supposed to be between 0 and 2 pi. Which of these answers doesn't belong?
17.
Why doesn't 17 pi over 8 work? It's beyond 2 pi. 2 pi would be 16 pi's over 8. 17 is too big. Does that make sense to you? So even if you didn't know, like, do I just go around 2 times or 3 times or 4 times? At some point you'd get to there, and if you think to yourself, oh, 16 pi over 8 is fine, but 17 pi over 8 is too big. Okay? All right, questions on that? Okay, let's try the next one. Yeah, that's it. These are your answers right here.
Why do you have to go one?
Because when we solved, we were solving for twice the angle, and we still needed to get theta by itself. So one more step to get theta by itself. Okay? All right? Okay. We couldn't divide by 2 beforehand because that 2 is trapped, so we had to take it out of the cosine function first. All right. Here, this is weird. Secant. I don't have secant on my unit circle. Okay, so what we can do then is think, I don't know secant, but all I need to do is change it. Sorry, not 3 pi. That's supposed to be 3 theta. If secant is -2, what's the cosine ratio going to be? -1/2. Yes. Mm-hmm. So all we have to do if we're using the reciprocal function is take the reciprocal of our ratio there. Okay, so I didn't flip anything inside here because that's Okay. Now we can go to our unit circle since cosine is isolated already. And we say to ourselves, looking at my unit circle, where does cosine have a value of negative 1/2? 2 pi over 3 right there. Good. Negative 1/2. Good. 2 pi over 3. And 4 pi over 3. Very good. 4 pi over 3. Okay. Now, oh, this is 3 pi over 2. How many times do we need to go around the circle?
3. What second? 1.5.
1.5 times there, yeah. I don't really know, but 3 over 2 is 1.5, right? Okay, so that's 1.5. Then I'm going to count a little bit further. So this was 4 pi over 3, 5 pi over 3, 6, 7, 8 pi over 3. Is that right? Yes. Okay. So maybe that one, I don't know. If I really wanted to be sure, I could keep counting 8, 9, 10 pi. Does 10 pi, does that not seem right to me? 6, 7, 8, 9, 10. I guess it is. 10 pi is over 3. Maybe, I don't know. I don't know if I need it. So I just wrapped around a couple times just in case. So we were solving for this weird angle here, 3 theta over 2. I still need to get theta by itself. So what do we need to do? Yeah. Multiply both sides by 2 over 3. And that is, those will reduce, leaving theta by itself. So what is 2 pi over 3 times 2/3? 4 pi over 9. 4 pi over 3 times 2/3? 8 pi over 9. 8 pi over 3 times 2/3? 16 pi over 9. And then the last one there would be 20 pi over 9. Which one's too big? 20 pi over 9 is too big. Why? 2 pi is equivalent to what? Over 9. 18 pi is over 9. So 8, yeah. Times by 9, top and bottom, you get 18 pi over 9. So 16 is fine, but 20 is too big. So these are great answers. All right. All right, you have questions for me? Those are tricky. All right, you guys have fun.